Hello! Today we're going to discuss how to do limiting reagents. I've picked a problem for us. It's problem 350 in your book. So if you want to look that up and work along with me, just pause the tape, look that up, and let's work together. Okay. The problem states to calculate the max number of moles and grams of iodic acid that can form when 63.5 grams of iodide trichloride reacts with 108.5 grams of water. Now this is the reaction they give you in your book. It says to balance it. I've already done that for us because we're just talking about limiting reagents today, but you might want to do that for practice. So, looking at this problem, the first thing you should recognize is that this is a limiting reagent problem. You see, you have two things that you're starting with over here, iodide, trichloride, and water, and they're asking you how much of this you can make. So, with a limiting reagent, the basic idea is that the reaction won't go forward unless you have everything available to react. It's kind of like if you had one bicycle frame and 3 bicycle tires, you can only make 1 bicycle, even though you have that extra tire. Okay. So in the same way, we're creating this iodic acid, but if you only have 2 moles of this and 2 moles of this, you can't make a whole mole of this because you need 3 moles of water. So, now we've talked a little bit about what limiting reagents are, okay? Let's talk about how to attack this problem. One way that I like to attack a problem is to first identify what I've been given. Now, in this problem, you've been given that we have a starting 63.5 grams of iodide trichloride and 118.5 grams of water, okay? That's all they've given you for this problem, okay? The next thing that's really good to identify is what you want. What you want is the answer. So what's the answer in this problem? Calculate the max number of moles and grams of iodic acid. So that's what we want to go after. I normally will actually like to separate what we've been given and what we want into 2 categories. And see, a chemistry problem is like a puzzle where you have the end piece, you have the beginning piece, and you need to find out what's in the middle. What's in the middle is what you need. Okay. Now in this particular problem, we're trying to calculate for moles and grams of iodic acid. Okay, and we're given these initial things. All right. The only way to relate 2 chemicals in a formula is through molar masses. Or through moles rather. So we need to figure out how to compare the moles of each of these to the moles of this and identify which one of these is going to run out first. Okay? So we need the molar coefficients in the chemical reaction. Let's look at that again. As you can see, for every 2 moles of iodide trichloride you can make 1 mole, see there's a 1 here, of iodic acid. Okay? And for every 3 moles of water, you can make 1 mole of iodic acid. So, we now know these molar coefficients. We know that there are 2 moles iodide trichloride for every 1 mole of iodic acid, and that there are 3 moles of water for every 1 mole of iodic acid. Okay, so now if we can figure out how many moles of each of these we have, we can figure out how many moles of this each of them can make. So let's do that calculation very quickly. Now we need to convert from grams of iodochloride to moles and grams of iodic acid. Okay? So we start with grams of iodic chloride, and we're going to immediately convert that to moles because remember, we can only get from one thing to another in a chemical equation through moles. So we convert grams to moles of iodic chloride. So we can cross this out. Then we convert moles of iodic chloride to moles of iodic acid. And remember, the reason we can do this is because of the chemical equation that we balanced earlier. Now finally, we convert moles of iodic acid to grams of iodic acid. And the answer to this is 23.94 grams. You can do that calculation yourself to check me on it. So, that's how much iodic acid iodochloride can make. So, remember, we could make 23.94 grams of iodic acid using the iodochloride. Now let's see how many grams of iodic acid we can make with the water. Remember, we were given 118.5 grams of water, okay? Using the molar mass of water, we convert to moles. So that crosses out grams. Then, using the molar coefficients from the chemical equation that we balanced, we convert to moles of iodic acid. And then, finally, using the molar mass of iodic acid, we convert to grams of iodic acid we can make from this much water. And the answer is now, remember what we said about limiting reagents? The reaction will only go as far as the one that can go less far. So, the iodotrichloride can only make 23.94 grams of iodic acid. The water can make 385.81 grams of iodic acid. But we will only make 23.94 grams of iodic acid because once this is used up, the reaction goes no further. Now, what's really cool about doing this problem this way is this is one of your answers, because this is how many grams of iodic acid you can make using these reagents. So you have the grams. To get the moles, you just need to go through this calculation for iodotrichloride and not do the last step, because you'll see from the equation that we did together earlier that you already had the moles and we converted into grams. So that concludes our study. I hope that you learned a lot.